All right, here we go. We have those article reports. I will be grading those by the end of this week. Um, just FYI, I've got a big jump on grading all my classes got turned in papers this past weekend. So little by little, I trickle them in, and I tend to do it based upon when they were turned in first. So I have 2 online classes, and they all turned in their papers on Friday. You all turned yours in on Saturdays, so I will be getting to yours over the course of later this week. Um, and we will have this class being the 19th and the 21st to cover Chapter 11. And that will overlap into Chapter 12 because I'm going to be gone, like I've mentioned in the prior classes. I'm going to be gone definitely Friday. We'll have to see how Monday goes. I'm in a conference. I'm not sure if I can juggle the conference and our meeting. So, but what I'll do is I'll have some recorded lectures along with a video to complement the lecture. So that will be coming. I'll have that out by the by Wednesday, end of Wednesday or Thursday. I'll have that up for Friday's class for sure. So, are there any questions about the schedule? All right. Well, are there any questions about anything at all at this point about life? All right. So we have last week we had covered the different models, the complete replacement model and the combination and the regional continuity model. Those are 2 polar sort of contentious theories of explaining the relationship between pre-modern humans and modern humans. And so what we always land on in science, typically, when we have these competing theories, is somewhere in between. And this combination model of most likely there was some interbreeding, and it probably happened pretty close to being out of Africa, right out of Africa, somewhere there in the Middle East. But potentially even in Europe, but most likely Europe was more of a complete replacement, but there was some interbreeding that happened early on in the passage of modern sapiens moving up into Europe and Asia. So you have to go through that funnel of interbreeding, that sort of place of a passage into Europe and Asia. Then that's going to create a genetic impact for populations elsewhere in Europe, Asia. So, yeah, this is the combination model that combines both regional and complete replacement. So we have within the genetic realm, we also have the conversation about the most recent common ancestor, the MRCA. So just to keep that kind of in your familiarity as far as language goes and acronyms, MRCA, most recent common ancestor. And if you do a family tree, and I highly recommend just as a kind of you have the capacity, you have the access to the knowledge. Many folks do not, but if you do, take advantage of it and trace it. See who you know is your most recent common ancestor. It's the elder of all your ancestors that you know of, dating back how many generations. Well, genetically, that can get your genetic sampling done, and you can go even deeper. And this is a little bit of an exploration of how this works. By the way, can you all see my screen? Make sure I'm not. Okay, I think something just. Were y'all not able to see my screen at that moment?
No.
Oh, okay. I was talking without any reference points. Well, let's. Now, can you see it?
Yes, we can.
All right.
At least I can.
All right. Thank you.
I can see it too.
Okay, great. Oh boy, this is not a good start for technology with me. But, all right, here we go. So, as I was saying, you have the genetic evidence that gives us a little bit of a larger picture of our migration, and we can date individualized specimens, but the genetic evidence that is collected all over the world on a daily, hourly, moment-to-moment basis, because people are pretty obsessed with the exploration, and many private companies are making a huge profit off of it. And I highly recommend doing it, but also highly recommend keeping it as a grain of salt, because there are recent reports that, for example, there was an African American woman who did her test, and she sent it off and sent it to, I don't know, maybe 23andMe or one of those major outlets, and it came back that she was only like under 10% African American. It was like it was single digit, and to the point of insignificant. And she knew that well, she knew that she was biracial, and she identified as African American for all of her life, and suddenly she's being told she's not. So she sent it off to three other organizations, and they all came back at the same time with different percentages, which throws into question how accurate are those things. Well, yes, the more genetic information that gets donated, actually it's donated, you pay for it, so I don't know, there's some sort of donation, but you're paying for your donation. It's a weird dynamic there, but the more complete the picture is, yes. But definitely, this woman at the same time was getting different results from each. And each has a different database that they're working from, because they're working from the genetic domain that they've collected. So anyway, that's just a little FYI in case you do go down that road. I do think it's informative. I do think that it is useful. I do recommend using National Geographic as your outlet if that's the direction you go. So anyway, there's a most common recent common ancestor, MRCA, and we are looking at as far as two different sources for DNA, mitochondria DNA and Y chromosome. So you got the mitochondria Eve, which is, of course, these are just symbolic individuals that represent a cluster, a group. There's not one individual that we're talking about here. There's not one single Eve, not one single atom. What happens is that we go through, scientists have gone through and collected genetic material from people all over the world, of course, with the goal of trying to establish the mutation rate. And the mutations are what establish these markers around the world that allow you to see how your DNA has traveled over time. And each new mutation creates a new haplogroup, um, those markers. And I I did this, and I did this early on. I need to revisit it to see what they knew of mine, because I did mine 15 years ago, I guess, and kind of early on in the early stages of their collection. Um, and I did do it through National Geographic, and they did show that I have markers that go down into the south of Ireland, and definitely was a Irishman. And my family's been telling ourselves that we're Scot-Irish, which there's a big difference between Scot-Irish and Irish, believe it or not. I won't get into the weeds of that, but and not only that, but that my family had been traced by a single genealogist, because I put my markers into the larger database, and a genealogist um, pulled me up and said that I'm the son of Dwayne, grandson of David, et cetera, et cetera, et cetera. Just named me, and it was spooky and freaky. Um, but it also she told me that I descend from a lineage of a king of Niles that goes back like 13th century. So anyway, that is um, individually it's interesting, but I think that even more importantly is what we're doing with anthropologically is learning about ourselves in relationship to the larger human story. Um, we have 18 major haplotype groups now. 18. 18 mutations that have established a different group. Um, and and so what we have in these mutations, you've got two different sources, like I mentioned. You have the mtDNA, that's the mitochondria DNA. Everybody remember how is the mitochondria DNA and how is it passed down as far as um, uh, lineage goes?
Are you talking about the Y chromosome?
No, the mtDNA.
Oh, okay, I don't know that one. I know the Y chromosome, though.
Yeah, so yeah, the Y chromosome is pretty obvious, right? What's the Y chromosome going to be tracing?
That's male lineage, right? From father to son.
Yeah, yeah. So the Y chromosome is father to son. The mtDNA, remember the mitochondria is that energy factory in your cells that is producing energy for your cell metabolism. What's the process that's happening in your cells? So, but it has DNA that is passed down through the mother, and so it's the matrilineage. So that's where we get our Eve. And with Eve, what we're talking about here is a mutation rate of about every 3,500 years, there's a new mutation on average. So the number of mutations, we're able to calculate how long a group of people have been living in that region. So the more mutations you find in a group, the more haplogroups you find within a single group indicates that that group has been together for that many years, or on average. It's pretty. It's a a window. Um, we're talking about 16,000 base pairs. I mean, we're going back to our world of the DNA conversation we had at the beginning of the semester. 16,000 base pairs. It's not that many, because the Y chromosome, which is passed down through the male lineage, obviously, does not recombine with the X, and so it is a direct line between males. It has a significantly larger set of base pairs, about 60 million base pairs, and it mutates a lot slower than you find in the mitochondria DNA. So it's an interesting dynamic you find here, because in the male lineage, because human history is so littered with polygamy, where one male marries multiple females, you get these bottlenecks of genetic bottlenecks where the spread of the Y chromosome becomes sort of stagnant and less profuse. So yeah, this is the two sources, the two um, um, collections of markers for our DNA and the foundation for what we know about the most recent common ancestor. So what have we found here? Based upon the mutations and the average rate of change that we find in these mutations, Eve is said to be somewhere around 150 to 200,000 years old as far as the lineage goes. Adam is said to be around 100,000 years old. It's been 120. It's been expanded to 120 to 306. Like I said, the more people that donate, the more people who give to the genetic database, the more information that we can um, more accurately use to calculate this number. So this is not, like I said, it's not one individual. And actually, this can change because a haplogroup, a lineage, can actually die out. And so, if there is no continuance, if that genetic haplogroup is not, if that code is not continued to be passed down into the next generation, then it dies out. And so it can be, and therefore then the marker becomes the Eve becomes, it moves forward. Um, so this is Eve and Adam we're introducing here to our understanding. So make note, 150 to 200,000 years ago, if that is the roots of modern sapien based upon the mtDNA, that is definitely indicating that we're talking about Africa, and Africa is um, the location where you have the most diversity um, of any population, genetically speaking, than anywhere else in the world. And this, we know this because of the mutations that exist in Africa, and it is by far, when you talk about genetic diversity, there is more diversity, genetically speaking, in Africa than anywhere else in the world, to the point of that if the rest of the world died out and just went extinct, zapped, gone, you have enough diversity in Africa, genetically speaking, to reproduce the diversity in the rest of the world that had died out, to repopulate the world and rejuvenate the diversity that exists elsewhere. That's how much diversity you have in Africa. And that says to us that Africa is where we all are from, genetically speaking. It is undeniable. But you can also look culturally in Africa. You have 5 cultural families of language. And that's massive. That's massive. Um, Language families are take a cultural anthropology course. We somewhat go a little bit into this. Is a huge, because there's many different languages within one family. There's hundreds sometimes. 5 major families shows that the human diversity, culturally speaking, as well, is very, very strong in Africa, like nowhere else in the world. You compare that against Native Americans. Native Americans have only been, we're talking about 15,000 years ago at the top range of as far as their presence in the Americas. And so, yes, they are in a sense young as far as the indigenous population compared to Africa, where you have 150 to 200,000 years of having been in the same place. And in the world of genetics, genealogists, they want populations that are old. when you have all this, like in America, where you have this mixture of genetic sort of um, di- the diversity based upon migration, the fact that Europeans, Asians, Africans, Native Americans, you know, have migrated here, and now we're intermixing with each other. We are a very youthful population, genetically speaking. They want genetics people want populations that are old and have been somewhere a really long time. That's where they want to get their wealth of information. Um, Indigenous people are very important to this conversation. However, um, why are they reluctant to give? Why would they not give? Because it is kind of an issue within the world of anthropology. I mean, they are definitely reluctant. Why would they be reluctant? What do indigenous people have? Why would they have a problem with giving their DNA over to European Westerners? Should they trust us with their DNA? What's
I
the
mean,
history?
probably not, considering like American history and what the government has done to Native Americans. So probably not.
Yeah, exactly.
Track record doesn't really speak for itself in that case.
No. They really should not trust us with their biological, um, essence. um, and some of them actually, um, it is something that this counter their religion, to not be buried with their entire physical apparatus. So donating blood is actually something that is a taboo. So yes, that is the problem. That's the challenge. We definitely um, you know have good, and most scientists have good intention, but definitely information could be knowledge can be knowledge is power, and power can be corrupted, to say the least. Um, Genetic data does not give us a window into what these people look like. Um, well, Samantha, yes, I don't mean to exaggerate that, but there are certain groups that do not believe in, and it's the small groups that I've talked about in the cultural class, Yanomamo in South America, for example. Um, they are. Um, it is taboo to be buried without all your parts and all your physicality. Um,
Yeah.
and what happened in the Yanomamo was Napoleon Chagnon was an anthropologist, went down and collected a bunch of genetic samples and blood samples, and took it back to the states for the scientists at his university to evaluate, and never returned it back. Samantha.
Yeah, gotta wonder, how does that work for women in menstruation? You don't exactly get that back.
Yeah. Well, that's the natural biological processes. I think that's maybe a little bit different, but yeah, you're right. It's a little bit of I guess you could say an exception in the rule, but and I am speaking very much well with an anecdote of talking about the Yanomami, but they are an example of a native indigenous tribe that believes that they should be buried with their entire apparatus. And so it's an example of a Western scientist who went in, collected blood samples, took it back, and created a study out of it, created a bunch of um, a book out of it, and did not return it, did not honor his word, and to say the least, set a bad standard for other Western scientists.
If I remember correctly, wasn't he banned from ever going back?
Yeah, he was. and he also lost face in the world of anthropology, um, although he kept his position, his tenure position, and he kept on publishing, and he kept on being himself an arrogant bastard. But that's it's a different story. But his contribution to anthropology is quite large, and I still make reference to him and his work because it's significant in time. But he definitely has some ethical issues, which anthropologists have to deal with for sure. Um,
You're speaking of the donating blood not being allowed in some cases. I actually, when I lived in Central America, I knew a guy who had a similar deal going on. He also wore a wristband saying that he couldn't receive or give blood in a case of an accident because of his religious,
huh?
you know. So
Yeah,
that was another thing. Actually,
yeah.
I asked him about it at one point, but
I actually, there's probably significantly more than I'm aware of, to be honest with you. So that makes sense. But yeah, that's it's interesting. It's interesting though. I mean, wonder how many groups are out there that definitely are kind of have some sort of built-in religion, um, that some sort of religious ethic or moral orientation towards that. Um, yeah, no. Keep preserving our body and our is in a sense a track record of who we are. So um, it's an interesting phenomenon. Um, so this DNA is a window into a genetic story, but it is not a window into what these specimens look like at the time, 195 to 200,000 years ago. Um, and if you look at the DNA, I mean, if you look at the fossil record, it is the other side of the story. And what's really important to note here as we look at this is that the stories between the DNA and the physical fossil, they are they're paralleling each other. It makes sense. It's sort of the stories work together with some exceptions, of course. So the Homo sapien, when we talk about Homo sapiens, so Neanderthalensis is referred to as now today Homo sapien neanderthalensis, as in a sense like a subspecies of Homo sapiens, because we have genetic overlap um, in Europe and Asia, but not in Africa. Okay, make note of that. Um, so yes, when we see Homo sapiens, typically, I don't have it written here, but typically you'll see Homo sapiens sapien, indicating modern sapien. Um, and so with this modern sapien, you find a um, mosaic of evolution, of course, like we've talked about. But the most prevalent features that we find is a vertical forehead, a forehead that is literally um, there is no recession, no receding aspect, or no bulging aspect. There's more of a vertical rounding. Um, Small brow ridges. Brow ridges are very much almost as we've seen with Neanderthals, in comparison, just kind of barely there, almost insignificant. Um, so that skull, that area of the skull is you find a lot of variation. Um, but what you find in modern sapiens that is pretty significant as to the signature and a trait that you can sort of count on being consistent is that chin. Um, and the chin is definitively there as opposed to Neanderthal, which basically there is no chin, it just drops down. Um, so that distinctive chin is also combined with two features, and we'll take a look at more closely the pyramidal mastoid and the canine fossa. So these two features are like very subtle, and you're not going to see it like you see this chin sticking out. So that chin is really something that's kind of um, very pronounced and very much in your face sort of thing. However, these other two features, for example, the canine fossa, is something you have to sort of definitely peer down into and see it as a microscopic almost, but it is above the canine, um, and it is this sort of indention. Um, and it's, as far as what its significance is, as far as functionality, it's not important, but it is a feature there that is that creates a thread for identifying. Oh, this is a modern sapien, and I so wish I had the lab exercise at our availability to um, to be able to do the detective work, because I had this lab exercise I used to do in California. I've mentioned it before. It's called Sherlock Bones, and you're given a specimen with only so many different aspects of the cranial and the postcranial, and you're supposed to identify the race, the gender, and the age based upon the information that's given to you. But this is one thing that you look for. This is one thing that you can look for if it's available to you. Another thing that you look for is what's called the pyramidal mastoid, and this is very mastoid is I think Greek for mistaken Greek for breast, and so it's said to look like a female breast, and as you see in the square there, as a very very subtle but very present pyramidal shape bone growth, and it is for muscle attachment. Actually, it does have some functionalities behind the ear, and maybe be able to fill it out if you play around with your behind your ear area. It is there for a little muscle attachment. So anyway, not important to know about its function, more about this is just a signature that they're looking for when we are looking for identification. So another sort of very subtle feature that we use to distinguish a hominin, and that is, we've talked about already, and that is this shovel-shaped incisor. The shovel-shaped incisor is something that you find in Asian populations, not 100%, but a very dominant feature you find in Asian populations that you don't find in European modern sapiens, and so, or African populations. So the trait goes back to erectus. As we've talked about, this is a trait that shows some potential continuity between Neanderthal, erectus, Neanderthal, and into modern sapiens in Asia. In Asia, and again, um, that shovel-shaped incisor, that feature is, there is real no biological evolutionary advantage to having that shovel shape. It doesn't give any sort of significance. It's a trait that was passed down. There is some thought that maybe it disappeared and came back into modern sapiens, disappeared after erectus and came back into modern sapiens, but that would mean that it has some sort of important functionality. But this is not seemingly that important to one's survival to have that. Seems like it would make it more difficult to brush your teeth, floss. Anyway, so that's important, really important to note of this shovel-shaped incisor, to sort of throw a wrench into the complete replacement, to say the least. This is one for regional replacement, or regional continuity, excuse me. So in the postcranial world, you have a Samantha, is it only present in adult teeth? As far as the shovel-shaped incisor, I don't know that for certain, to be honest. That's a good question, because, for example, the canine fossa, no, it is, I think, the I'm not for sure. Some because some the other, I think this feature, the canine fossa is something that comes in adulthood, if I'm not mistaken. But I'm not for sure about the children's, the baby teeth, if this is something you find in baby teeth or adult teeth. It's a good question. Another in the world of the postcranial, a feature that we need to make note of is the long pubic ramus part of the um, uh, postcranial world of the birth canal is important in this feature because it used to be thought that Neanderthals had a birth canal that was to allow for a longer incubation time for the brain to develop inside. Um, the hip bone of the Cro-Magnon, which is a modern sapien, early modern sapien in Europe, um, is very similar as far as in relationship to Neanderthal. There is some difference. The Neanderthal is more turned out, um, but the modern sapien definitely has a different shape to it. But there's similarities. So what they boil down to is really the birth canal of the moderns of Neanderthals is about the same as modern sapiens, um, and so it really the pubic ramus was a little bit thinner and more slender actually in modern sapiens, but in essence, what the Neanderthals have in that width of their um, of this region, they have a little bit of a wider um, pelvis. It allows them for better climbing and to live a more rugged lifestyle. Um, so when we're looking to the pelvis, there's not really something that is very significant in the difference between modern sapiens and Neanderthals. There's some overlap, but there's definitely some shape differences because Neanderthals lived in a different habitat. They lived more in quote unquote nature. They lived a very rough lifestyle, and so their pelvis was adapted towards that more so than to set off their how they gave birth and what stage they gave birth in the brain's development. So with the fossil record of Homo sapiens sapien, as you see, this tells a little bit of a story in itself, just looking at the dates um, from 120 to 195,000 in Africa. That's the oldest um, fossil found of modern sapiens in Africa, up to the Middle East in Skull, which is Israel area, 110,000. Moving on into Australia at 50 to 60,000 years, and Asia, Indonesia area at 40,000 years, Americas 15,000 years, and of course, don't forget Europe at about 28 to 40,000 years. These are the earliest fossil findings of modern Homo. So, yeah, there's a story. We're going to look at a couple of these. And first, of course, we have to start with the oldest. But you have to look at each individually. Each individual area has to be taken on its own accord. Um, and you have to ask, relationship to the pre-modern specimens that were there before, what's that relationship like? Is there a evidence of continuation, or is there evidence of replacement? And so, there's going to be a judgment call that's being made. And how similar does that fossil have to be to define a completely modern specimen? And it's subjective, in other words. I'm trying to express it. There's a subjectivity to this. you can say that some of this variation that you find in modern sapiens from Africa down to Asia could be based upon what we call interest-specific variation, interspecies variation. So there's variation between species members that could account for the variation that we find. So anyway, we've talked about this, those splitters versus the lumpers. Local indigenous people like to split. They like to say this is our individual and it's specific to us. So intraspecific variation is something that is lumps. The recognition of intraspecific variation lumps together a larger collection of specimens. In Africa, you have like we mentioned, a number of specimens that range from 120 to 195,000 years old. And what was happening in Africa with modern sapiens, that was a world unto itself compared to Europe, where at the same time, Neanderthals were evolving. So in Europe, you had the work of Neanderthals and Heidelbergensis at this time, but in Africa, you have this evolution of modern human form. And there is some thought, like I mentioned, of course, each of these we look at individually, that potentially what you find in Africa could have been a subspecies of modern sapiens. But it is taken on account of lumping them together. It is the most complete set of evidence, physical evidence of modern sapiens. So this will be a good place for us to pick up. We'll pick up with looking at, we're going to travel through the fossil record on Wednesday, and yeah, that seems like a natural place for us to land on. Then Friday, we'll do some. When I'm not here, I'll have an assignment around the culture of modern sapiens. So, all right. I'll hang on for another minute or two if anybody has any questions. Everybody else, you have a good rest of your day, and I'll see you Wednesday.
Thank you much. Have a good one.
Thank you.
Thank
Have
you.
a good day.
Bye-bye. Good day. Enjoy the sunshine.